Imagine you're trying to describe a mountain range to someone over the phone using only numbers. You can't send the whole mountain, so you take measurements of its height at specific intervals. This is what an ADC does. It takes an analog signal, which is smooth and continuous, and samples it at specific times. It then assigns a numerical value to each sample. These numbers are what your computer or Arduino uses to see the real world. The accuracy depends on resolution. A 10-bit ADC, like the one in an Arduino Uno, divides the voltage range into 1,024 steps. Then there is the sampling rate. To capture high-quality audio or fast sensors, you need to sample thousands of times per second. If you sample too slowly, you get aliasing, where the digital version looks nothing like the original. Most microcontrollers use SAR ADCs, which act like a balance scale, quickly testing different values until they find the closest match to the input voltage.